Okay, this is a quick video just to go over a little point about polyatomic ions. Polyatomic ions are bonded together. They're groups of atoms that um, that are bonded together by covalent bonds, but they have a charge to them. And the reason they have a charge to them is because they either have one more electron than necessary or one less electron than necessary. Um, well, necessary in order to make a neutral substance. For example, let's say you have the polyatomic ion nitrite, NO2 with a negative charge. That negative charge comes from the fact that in order to give a stable structure with octets for all three atoms here, you had to have an extra negative charge. Okay, and so whenever you have a polyatomic ion, you want to write a Lewis structure for a polyatomic ion, you're going to need to go ahead and add one electron extra than you would normally have when, these are the valence electrons. You would want to do one extra electron than you normally have in order to be able to um, get the octet for all the atoms. If you have two negative charges, you're going to need two of them. Three negative charges, you're going to need three extra ones. If you have a positive charge, it means you have to take away one. Okay. So let me show you on nitrite right here. Remember that it's made up of nitrogen. All right, and the nitrogen has 5 valence electrons and 2 oxygens, and the oxygens come with 6 valence electrons. Okay, and then we're going to have that twice. So in order to put these together, let's go ahead. I'm going to put the nitrogen in the middle. Okay, I've got nitrogen with with its electrons right here. Then I guess I'll use red to make the oxygen. And the oxygen, let's say I put one oxygen over here, and it has its 6 electrons. 1, 2, 3, 4. 1, 2, 3, 4, 5, and 6. I'll put that down there. And another oxygen over here. Make a bond with that nitrogen here. 1, 2, 3, 4, 5, and 6. So you can see here that the nitrogen only has 7 electrons around it. Same with this oxygen, this oxygen. All the atoms they don't have an octet. But what we can do is we can go ahead and make an octet for nitrogen, one of the oxygens, by moving these electrons in here between the nitrogen and the oxygen to form a double bond. And now we're going to end up with what would be nitrogen, and then we'll have 2 of the electrons here, these guys up there, and this one right here. And then, so those are the 5 electrons on nitrogen. We've just moved them around a little bit. You can move them around. This oxygen over here, this first electron right here was this one right here, and then the second electron right here was the one that was moved in to make the double bond. And these guys will go ahead and do that. Okay. And if I go ahead and draw the other oxygen that was here, and I draw its electrons in where they were, so at this point, this oxygen has its octet of electrons, 2, 4, 6, 8. Let me go ahead and draw that in. I don't know. Go ahead and do that. That's an octet of electrons there. Okay, that's good. There's 8 electrons around the nitrogen. That's good. But now the oxygen, this oxygen over here doesn't have 8 electrons. It's only got 7. So it's still missing 1. This is where the extra electron comes in. I'm going to go ahead and put it as a purple one. I have to bring an extra electron in from somewhere else, somewhere we didn't start off with. And that is our extra electron. And we go ahead and put that on there, and we're going to end up with 8 electrons here around this oxygen. See, this wouldn't have worked without that extra purple electron. And once again, the colors are just to show you where they came from. Okay, that purple electron is just purple because it shows that it wasn't one of the red ones were the ones that originally came with the oxygens. This one came from somewhere else, probably some metal that that give up an electron while this was happening. So we can write the Lewis structure. The formal Lewis structure would look like this. You got a nitrogen here, double bond to the left. Oxygen has its electrons there. Here you've got your nitrogens there, bond here, and you've got electrons over here. Okay, and this whole thing gets put in a bracket. When you have a polyatomic ion, you put in a bracket. You put the charge in the upper right. Okay, this shows the whole thing is a -1 charge because you have one more electron than what you start off with. Okay, that's how you handle a polyatomic ion. Let's do one more. Now that's what I showed you kind of how to put it together and how, by moving the electrons around, we ended up with the point where we're just still missing one. I'm going to basically kind of show you acetate, and acetate's kind of already been done here. So acetate is C2H3O2 minus. And the way acetate's put together is the two carbons are put together. And the three hydrogens actually go on one of the carbons. And one of the oxygens is double bonded to the carbon. The other oxygen is single bonded. And if we just use the electrons that it came with, this would be a neutral molecule and wouldn't give us an octet on this last oxygen, right? So if you counted how many electrons come in this ion, right? There's two carbons, that's a total of 4 times 2. Right? 4 valence electrons for carbon times 2. Plus 3 hydrogens, that's just 3. Plus 2 oxygens, so 2 times 6. Right? 6 valence electrons times 2. You would expect to have 8 plus 12 is 20, 23. 23 electrons. So here we got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23. It's not going to work, though, unless we bring in an extra electron. And so here we bring in an extra electron just like we did nitrite. If I bring in this extra electron right here, now it's got 24 electrons, and now it gives this oxygen an octet. Now everyone's got an octet, everyone's happy, and the whole thing is put in a bracket. It's got a -1 charge. Okay. So polyatomic ions, if you have a -1 charge, that means you have an extra electron, and you're going to need that extra electron in order to make an octet for all atoms that require octets. I haven't talked about this, but there are some atoms that, some elements that can go beyond the octet, like phosphorus and sulfur. Elements from groups in rows 3, rows 4, but rows 2 always have to have an octet. And I'll talk about that why later on. Same thing here. We added that extra electron. That's what gives us that negative charge. Okay, so just a quick video on a Friday, just to kind of clear things up, because some of you guys might be feeling a little confused as to how to put together the polyatomic ions.